Hi, my name is Henry Martin, and I'm moving into the 7th grade at the Gold Miner School. Earlier this year, I was given the opportunity to participate in the 2022 Aerospace Jam. This was our drone for said jam, inspired by the upcoming Artemis mission. During the jam, we were tasked with outfitting a drone with several sensors to collect data from multiple sources, including measuring the distance between 2 points, reading the color of a surface, and taking a soil sample.
The drone itself is a kit that our team assembled and customized to fit our needs. The sensors are driven by an Arduino Nano, which receives commands from the Bluetooth module and then transmits back data from the respective sensor. If the command requires a lighting change, for instance, if a color is read from a surface via the spectrometer, then a command will be sent from the control Arduino to the lighting Arduino, which drives the array of lights found across the bottom of the drone. In order to send and receive data from the drone, we also use an app created in MIT App Inventor, although any piece of software that can send text via Bluetooth would work in its place. The drone is also equipped with an array of sensors that allow for it to fetch data from its environment. The first sensor in the array is the LiDAR sensor, which can measure the distance away from an object. For instance, if I set my hand in front of it and then press the LiDAR button in the control panel, you can see that it thinks my hand is approximately 23 centimeters away. The next sensor in the array is the color sensor. It detects the color of the surface beneath it and converts it into a hexadecimal code or displays the raw spectrum readings. If I tap the color button, it will turn on the light and then detect the color of the object beneath it and display it on the lighting system. It will also display it on the readout beneath the buttons beneath the control panel. For instance, if I were to lift the drone and place this underneath it, and then tap the color button again, it would read a greenish color. If I were to remove this and add this yellow color, that would read as yellow. The second function of the color sensor is to be able to detect fragments of the spectrum. If I tap the spectrum readout button, it will give me a readout of each of the individual wavelength categories in the spectrum. The next sensor in the array, although it hardly qualifies as a sensor, is of course the dirt grabber. It has proven invaluable in sample collection in the past. It is powered by a simple servo and a custom printed grabber model. If I press the close button in the control panel, you can see that it closes. If I press the open button, it reopens. Next on the list is the moisture sensor. It can detect the moisture in the air or the moisture in the soil. If I tap the moisture button, you can see that it is currently at 0% moisture. However, if I touch it with my fingers to add an extra bit of moisture to it, you can see that it reads as 11% moisture. Finally, the last sensor is the Hall sensor. It can detect the presence of a magnetic field. For instance, if I set a magnet near it, you can see that the light turns on. If I tap the Hall sensor button, you can see that the app outputs that it is near a magnet. If I remove the magnet, and I tap the Hall sensor button once more, it will output that it is not near a magnet.
I really enjoyed this competition, and what I enjoyed most was being able to manufacture our own parts as well as working cooperatively with other teams. Thank you for your attention and for letting us share our work.